good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, in the previous class, we have discussed about the various graphs. We have discussed about displacement time graph, we have discussed about velocity time graph and acceleration time graph, and under those sections we have discussed the various types, isn't it? So from that we will be continuing our discussion today. Today we will be talking about or just discussing about the three equations of motions that are very important for the analysis of any motion. Okay, so what are those three equations of motions? So first of all, just take out your copy and pen and start making notes, because today we will be not only discussing about those three equations of motions, but we will also see how those we conclude or arrive to those equations of motions using some graphical methods. Okay, so make heading equations of motion. Equations of motion. So basically there are three equations of motion. Okay, so what are those three equations of motion? First of all, the first equation is V is equals to U plus AT. Second equation is S is equal to UT plus half AT square, and third equation is V square is equal to U square plus 2AS. Now remember one thing, what this S, V, U, A and T denotes. Okay, so at the side of your copy write what this letters denote. So first of all, if I come V denotes the final velocity. Okay, please note that these are actually velocity, not speed. Rather, it is better to say this as velocity. U is the initial velocity. U is the initial velocity. Okay, initial velocity. Fine. Then A means acceleration. A means acceleration. Okay. Then T means time. Okay, and S means displacement. S means displacement. Fine. S means displacement. Okay. So these are the notations that you need to know. Okay, so three equations, remember: V equals to U plus AT, S equals to UT plus half AT square, and V square equals to U square plus 2AS. These are the three equations. Okay, now so quickly let us see how we can come to these equations, or how we can find these equations using graphical methods. Okay, so I think you have noted down these three equations. Okay, and also the notations or the denotions that these letters give or denote. Okay, now we will be arriving at these equations using graphical method. So coming to the first equation, if I consider that the equation V equals to U plus AT, how can you come? So what does that mean? The V equation V equals to U plus AT, when you write this equation, it is basically denoting that an object has an initial velocity of U. Now when we actually apply some kind of force, we will be discussing this thing about in the next chapter. When we apply some kind of force, that actually causes an increase in the velocity of the body, and that final velocity is V. Okay, and for this it requires a time of say T, and the acceleration is being A. Now so how can we derive this equation? Now if I draw a velocity time graph, I think you can draw a velocity time graph. Okay, so if I draw a velocity time graph, okay, for a body which is having an initial velocity U, and then from that velocity U the velocity keeps on increasing and it reaches the value of V after a certain time T. Okay, so this is a velocity versus time graph. Okay, so on the y-axis we plot velocity, okay, and on the x-axis we plot time. Okay, so if I say that the body is already having some velocity of u when we are actually starting our time from t equals to 0, the body is already having some velocity u. Okay, so if I say this is the value of velocity u. Okay, so at t equals to 0 the body already has velocity u, and we are actually seeing the object or analyzing the object from that instant of time. We are considering that time to be t equals to 0 when the velocity is u. Now from that, if I apply an uniform acceleration the constant acceleration a, the velocity of the body will steadily keep on increasing, and say after a time t it reaches a value of say v. Okay, fine. And for this the time actually taken is from 0 to t. Okay, so the time taken is actually from 0 to t. Fine. So this is t time. Fine. Okay. So now how can you actually get the acceleration? How can you get the acceleration? So if we are considering a velocity time graph, and from that you want to find out the acceleration, what you need to do, you need to find out the slope of the graph. We have already discussed in the previous sections. We need to find out the slope of the graph. Okay, so if I consider the slope, okay, so here t is equals to 0, here t is equal to 0, so here t is equal to 0, and here t is equal to time t. Okay, now if I consider the slope of this portion, say we are considering two portions, this is part A and this is part B. I think it is visible to the video. Okay, now if I determine, how can I determine the slope of this line AB? We know that slope is determined by changing the value of y coordinates by changing the value of the x coordinates. Okay, so for determining the acceleration from this kind of graph, so acceleration is given by the, again we are writing, given by the slope of velocity time graph, VT graph, velocity time graph. Okay, velocity time graph. Now how the slope is obtained? So the slope is obtained by changing y by changing x. Okay, changing y by changing x. So if I consider this part AB, the velocity has changed from u to v, and if I consider the time change, it has changed from 0 to time t. Okay, so you can write, therefore acceleration is denoted by a, it will be given as v minus u. Okay, v minus u by t minus 0. So from this what we get? We get a is equal to v minus u by t, and from this we get v minus u is equal to at, and finally from this equation we get v is equal to u plus at. If we just move this equation on u, value of u on the right side, it becomes plus. So this is how we can actually come to the derivation or the formula. Okay, v equals to u plus at. So I think the concept is clear. V equals to u plus at. Okay, so if you have not noted it down, please note it down. It will be helpful for you to understand how to grasp the concept. Okay, so this is the first relation. Now what about the second equation? We know that second equation is s equals to ut plus half at square. Now remember, s is the displacement. Okay, s is the displacement. So how can you get velocity from a velocity time graph? How can you find out or determine the velocity displacement? For that you need to determine the area under the curve. Okay, so we are going to derive the equation for displacement. Okay, so I think you have noted it down. If not, please just pause the video, move back a little and note it down. So displacement is obtained from the velocity time graph. How can you obtain the velocity time graph? So it's the area under the curve. Okay, area under the curve gives the velocity. Okay, sorry, displacement. Fine. Okay, so there are actually two areas, isn't it? There are two areas. One is this rectangular portion. If I just consider the area under the curve AB, there are two areas. One is the rectangular area, okay, and another is this triangular area, isn't it? Triangular area. Fine. Now if I just mark this area as 1, okay, and mark this area as 2, okay. So what we get, we just need to add up the area of part A and part 2. Okay, fine. So here, so total displacement is equal to area under the part 1 plus area under the part 2. Area under the part 1 plus area under the part 2. Fine. Okay. So how can we actually get this? Okay, see. Now the area 1 is a rectangular area, isn't it? Now if I consider what is the length or breadth of the rectangle? Length of this rectangle is actually t. It's from 0 to t, means t, if you just subtract it, t minus 0, it comes out to be t. and if I consider the breadth, it is u minus 0, so u. So rectangle, you know, its length into breadth, so we can write it like this, that length into breadth u minus 0 into t minus 0. Okay, so this is the first area. Okay, and the second area second area is actually the triangular part. Now you know this is a right angle triangle. You can actually see from the figure. If I consider this figure, this part, okay, is a right angle triangle. Now this right angle triangle actually has a formula for calculating the area is half into base into height. So what is the value of the base? The length of the base is again t minus 0 means t, and what is the height? It is the v minus u. Okay, so if I consider this half, so it's half into base is actually t minus 0 into height is actually v minus u. Okay, so this is the area of the triangle, isn't it? Area of the triangle. Fine, area of the triangle. Okay, now so how can we actually, so this is the area of the triangle. Now if I just do the calculations, the rest is just simple calculation, nothing else. If I just do the calculation, so it will be something like this. Area of the rectangle is u into t, so it's u into t, and if I consider this part, so it's half into t into v minus u. Okay, so plus half into v minus u into t, isn't it? Half into v minus u minus t. Okay, fine. Now just the remaining calculation, just let me lower the camera a little bit, then it will be easier to see the board. Okay, now it's fine. Okay, see, now if I consider, so if I just do the rest of the rest is algebra, so if I just subtract this part or multiply and subtract this part, you will get ut, okay, plus ut plus what will be the value? Ut, so actually see, v minus u. Okay, so in the previous derivation we have done that v is equal to u plus at, isn't it? So what will be the value of v minus u? It will be simply 80. Now if I put this value of v minus u here, so it will be half into 80 into t, so finally it comes out to be half a t square. So this is your actually final expression for displacement. A is equals to ut plus half a t square. Okay, fine. So this is the formula. Fine. Okay, so I think the concept, the derivation is clear to all of you. Okay, a is equals to ut plus half a t square. Okay, fine. Now coming to the third equation, what is the third equation? V square equals to u square plus 2s. Now we do not need the graph in order to arrive at that expression. We can directly utilize the formula number 1 and equation number 1 and equation number 2. What is equation number 1? It is v equals to u plus at, and what is equation number 2? It's s equals to ut plus half at square. Okay, okay. So if from the first equation, now from the first equation you can do something like this. Okay, so just let me, have to substitute the value for t, isn't it? So how can we? Yes, we can easily substitute the value of t. Okay. So from the first equation we get the value of t as t is equal to v minus u by a, isn't it? And the second equation is a is equals to ut plus half a t square, isn't it? Fine. Substitute the value of t here. If I substitute the value of t, so it's equal to u, keep a bracket, v minus u by a, okay, u into okay, so it's something like this. Okay, fine. So half into, okay, so if I get the value of the t, so it's clear. Okay, now see. Okay, so what we need to do, we need to actually calculate the value of s, isn't it? Value of s, but we have to substitute the value of t here. So what we can do, we have to actually, okay, so we can either go by an easier method, as we are just moving by graphical method, so you don't need to apply any equation. Just we can also derive it from the graph. So just so you can also do it like this. If I consider what is the displacement of the body, in time t, then you can also say that it is, see, this is actually function trapezium, isn't it? A, B, say C and D. So these are the 4 points. Okay, C and D. So this A, B, C, D is basically nothing but a trapezium. So you know that the area of a trapezium. So if I consider what is the distance traveled in time t, distance traveled in time t, okay. So what is its value? Distance traveled in time t. So it will be equal to the area of the trapezium, isn't it? Area of trapezium A, B, C, D. Fine. Okay. So if I consider the area of trapezium, so it is equal to half into, what is the value of the area of trapezium? So it's half into sum of the parallel sides, isn't it? Half into sum of the parallel sides and multiplied by the distance between the parallel sides. Isn't it? So distance between the parallel sides. Okay. So if I see the parallel sides are this AD and BC, and the distance is CD. Okay. So it will be something like this. So half into this sum of the parallel sides, length of the parallel sides. So AD plus BC, isn't it? Into multiplied by the distance CD. So this is the formula, something like this. Now, what is value of AD? Its value of AD is U, okay, plus value of BC is V into time t, okay. Now again from the, if I just take the help of the first equation, t is equal to V minus U by A, isn't it? So just substitute here. I think the equation is visible, so substitute here. If I substitute this equation in the time, because in the third equation there was no term of time. So half into U plus V into, say rather write it like this, V plus U, it will be easier to understand. Okay, V minus U by A. Now V plus U, V minus U. What is this? A plus B into A minus B. If you just apply that formula, algebraic formula of A plus B into A minus B, so it will be half into V square minus U square. So this turns out to be half into V square minus U square, okay, by A. Okay. So this is the, actually we know that this is the displacement, isn't it? So basically therefore A is equal to V square minus U square by 2A, isn't it? So from this, if we just do algebraic manipulation, if I cross multiply it, so it will become V square minus U square is equals to 2as. So V square minus U square is equals to 2as, and from this you can come to the conclusion that V square is equals to U square plus 2as. Okay. So this is the formula that will come to the end. Okay. So these are the three equations of motion. You can actually practice these derivations. It will be helpful for your understanding of the concept. Okay. So today we will be actually ending our class here, because we have already finished this part. The numerical problems, we will be discussing few of the numerical problems on in the board, and we will be doing some in the in the digital class. Okay. So with that we come to the conclusion of this class, and we also come to the end of the chapter, but we will be taking one more class to just do the numerical problems to help you to understand the concepts a little bit better. Okay. With that, please do study well, and if you have any query or any problem or any doubt, please do mention in the comment section. We will be happy to solve your problem. Okay. So till the next video, do study well. Goodbye. Thank you.